let's look through paper 1, non-calculator for the AQA. Okay, so this is November 2018, and we're looking at the higher paper, but the first 7 or 8 questions are also the crossover questions, which will be both in the foundation and the higher paper. So question 1, simplify 5 to the 4 squared. So remember, whenever we have indices like this, what we're going to do is we're going to multiply both of these. So we get 4 times 2, which is 8. So it's going to be 5 to the 8. So you can then think about it, it's also 5 to the 4 times by 5 to the 4. And you can also think about it by doing 4 plus 4, which would also give you 5 to the 8. So that's using your indice rules. Then we've got to circle the volume in centimetres of a cylinder. So let's think about a cylinder. Here's a cylinder. So you've got your cross-sectional area up here, which is a circle, which is pi r squared, multiplied by the height, which is h. So what we've got here is we've got pi times 5 squared times h, which is our height. 5 squared is 25. So we've got pi times 25 times 8. We know that 4 25s make 100. So 8 25s will make 200. So we've got 200 pi. Right, here it's going to be how we use BODMAS or BIDMAS. So, no brackets. I'm going to do division first. So we've got this bit here first. We've got 16a squared over a. So that cancels and gives us 16a. Then we're going to do the multiplication bit. So we've got 3a times 2. 3a times 2, 3 times 2 is 6. So we've got 6a. 16 plus 6 is going to give us our 22a. Right. Question 4. Cos 30. Okay, so these you've got to learn. But say you're like me and you like to prove things and learning kind of just doesn't click when you're trying to learn these for 30, 60, 90, so on. We're just going to prove them each time. We're going to draw ourselves a triangle. So we've got a 2 by 2 by 2 triangle. So it's an equilateral triangle where all the angles are 60. Now what we're going to do to this triangle is we're going to chop it in half. And when we chop this triangle in half, we get a right angle triangle. So this angle up here is half of 60, so it's 30. This becomes 60. This is 2. This is half of the 2, so 1. And then if we want to find the other side using Pythagoras, 2 squared, which is 4, minus 1, which is 3, this becomes the square root of 3. So now, if we want cos, we go to so, ca, toa. So we've got adjacent over hypotenuse. For the 30, the adjacent is root 3 and the hypotenuse is 2. So it's going to be root 3 divided by 2. Okay, so next what we have is we want to give an answer as a mixed number. So we've got 8.5 divided by 2 2/3. Step 1, you want to convert them into fractions, into top-heavy fractions. So we're going to do 8 times 2, which is 16, plus 1 to give us 17 over 2. And we've got divided by 2 times 3, which is 6, plus 2. So to give us 8 over 3. Now remember, we kiss and flip. So we change the divide to a times and we flip. And now we see, can we cancel anything down? Diagonally doesn't look as obvious. Up and down doesn't look obvious. So we've got to just do the maths. 8 times 2, well, that's easier, that's 16. And then we've got 17 times 3. So don't be worried if you have to write a little times sum on the side. It's not a problem at all. Then how many 16s in 51? So you're going to go, okay, I've got 16 plus 16 to give me 32, plus another 16 is going to give me, you can just add them up there. So you've got 6 plus 2 to give you 8, 48, and I'm not going to be able to do any more. So I know there's definitely 3, 48, 49, 50, 51. That leaves us with 3 over 16. So we've got 3 and 3/16. Okay. So the next question, let's scroll up. A ship is sailing in a straight line from its home port. The distance time graph shows 4 hours of the journey. Work out the speed of the ship during these 3 hours. Okay, so whenever we want to work out the speed, so if we think about the formula, speed equals distance over time. So in the case of a distance time graph, it's essentially your gradient, which is your slope. So it's the steepness of your slope. So what you're going to have a look is you're going to try find the best place to draw yourself a triangle. So if you take the entire thing, if you like, so at 0 here, what do we have? We're going up in, so 5 squares is 20. That means each square is 4. So we're going to go up to 40, so that's 40, I've just covered it up, so that's going to be 48 and 0 there. And so we'll put 48 here, and up here we're going to 100 and, so we've got 116. Yeah. Okay, so if I look at the difference, so my gradient is my change in y over my change in x. My change in x is easier, it's 4 because there's 4 hours. And my change in y is 116 minus 46 to give me 70. And my speed then is going to be 70 over 4. So in order to do that easily, if you can't see it easily, always halving is easy. So 2 and 70 halved could give us 35, and we could half it again, and we've got 17.5. So your speed of the ship is 17.5. So next. The sum of the angles in any quadrilateral is 360 degrees. For example, in a rectangle, 4 times 90 is 360. Okay. Zach writes, 5 times 90 equals 450, so the sum of the angles in a pentagon must be 450. Is he correct? Well, you can't have a pentagon, can't have all the right angles, because it just wouldn't work. You wouldn't be able to put it. So you could draw a pentagon and you'd see that doesn't work. The other way is think of a pentagon. So what is a pentagon? A pentagon is a 5-sided shape. We know that if we take the number of sides minus 2 and times 180, we know what the interior angles add up to. So 3 times 180 gives you 540, which is not 450. So you'd say no, and you'd say a pentagon cannot have 5 right angles. Or you could say a pentagon's interior angles add up to 540. Okay, next. Kim works at an airport in the UK. She records the number of planes. We've got data for the first 10 days. The airport was affected by fog on one of the days. What day do you think it was? Okay, we look across and we see which one looks weird. This one here looks weird. So I'd say it was day 8. And the reason would be it's lower. All the other days were out of 140. It's an outlier. Anything along those lines. Just something that shows that you recognise that it's lower than the others, lower than other values. the others are all around 150. That one is significantly lower. Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes. Work out her prediction. Okay, so she's got 150 planes every 4-hour period. So we're saying, okay, in 24 hours divided by 4, how many 4-hour periods are there? Well, they're going to be 6. So that's 24 divided by 4 is going to give us 6. So we're going to have 150 times by 6, and we'll find out how many that come in every day. So 15 times 6, we know is 90. We add the 0 for 900. And then we're going to make the assumption that there are 365 days in the year. So we're going to multiply that by 365. So in order to multiply it by 365, we could either multiply it by 10, take away 1 and add some zeros, or you could do a sum where you do 365 times 9. So you'd have your 5 times 9 to give you 45, carry the 4, 6 times 9, add the 4, so 58, 9 times 3, plus the 5, which gives you 32. And then you'd have to add your zeros on the end. So you end up with 328,500. Right, next. In fact, fewer planes land in winter than in summer. Fewer planes land at night than during the day. What does this tell you about Kim's prediction? Okay, well then her prediction could be too low or too high, because fewer landings would make it too low, but fewer landings at night would make it too high. So it could be either because this statement here would make it too low, whereas this statement here would make it too high. And you would rewrite that, not too height, just too high. Okay. Question 9. So we're going to work out the value of A. Right, where would you start with this? So if you were going to start, I'd probably start with the right-hand side. It's probably left-hand side rather. So 6 squared is 36. 8 squared is 64. That gives me 36 plus 64, which is 100. That gives me 10. That's the left-hand side. So we know 10 equals the cube root, and we can split this out of 125 times the cube root of A cubed. The cube root of 125 is going to be something where you do something times something times something gives you 125. So hopefully you recognise that's 5. The cube root of A cubed, you're just getting rid of the cubed. It's going to be times A. So hopefully you can see that A must be 2. 10 divided by 5, giving you A equals 2. Right, we've got to work out the percentage increase from 80 to 280. So percentage increase is always the difference over the original times by 100. So your difference in this case is 200. Your original is 80, and you're multiplying it by 100. So you cancel out where you can. We can cancel out zeros there. We can make that 100, that 4. So divide by 2. Divide by 2 again. And then 2 and 10 is 1 and 5. So 5 times 5 is 25, and add the 0. So do as much cancelling out as you can, so you're not relying on your mental arithmetic to do big calculations. Okay, we've got 4 triangles. We want to find 2 that are congruent. Congruent means the same. So we want two triangles that are the same. So let's have a look. Let's think how we'll do this. Okay, if I have a look, for example, at the first one. The 8 centimetres is opposite the missing angle. So the missing angle will be 180 minus 25 minus 56. You don't really need to work it out, but if you wanted to, you could. That's 99. The 8 centimetres in this case is opposite the 56 in B. In this one, it's opposite the 25. And the 8 centimetres in this one is opposite again the missing angle, which we worked out as 99, but like we said, we don't need it. So these two are the two congruent triangles. So we've got A and D because the sides match. Okay, we've got a factorisation to solve. This one's an easy one. So we put two brackets in. Got x and x. 12 factors of 12 with a difference of 1. So we're going to have 4 and 3. That's going to be minus. So we want the bigger number to have a minus sign in front of it. And we're saying this equals 0. That means x minus 4 equals 0. Or x plus 3 equals 0. And this gives us x equals 4 or x equals minus 3. So those are your two answers. Two to 3. Now remember, this is the same, and F and G equals 5 to 4. So what you're going to do is you're going to line them up. So we want E to F to G. So we know E to F, we've got 2 to 3 here. F to G is 5 to 4. So we're going to see what's in the same line. So we can see the F is in the same line. So we're going to do 3 times 5, which is going to give us 15. And we're going to say, how did we go from 3 to 15? We multiplied by 5. So on this side, we're going to multiply by 5 and we get 10. Here from 5 to 15, we multiply by 3. So here we're going to multiply by 3 to give us 12. And now all we want is E and G. So we want that one and that one. So we've got 10 to 12, which can cancel down further to 5 to 6. Right, so let's have a look at this question. Step 1, we're missing a number. We're missing the number outside. So we're going to have to work out what's going to go outside. So let's add up what's inside. We've got 0.3, 0.15, 0.35. So we're going to get 0.8, which means 0.2 must be on the outside. Okay, so we want not A or B. So that means essentially we want all the bits that are in B, so we can circle those, but also the bits that are not in A as well, which is that. So that leaves us with 0.15 plus 0.35 plus 0.2, which gives us 0.7. So your answer is 0.7. In a survey, queuing times at supermarkets are recorded. We've got samples of 50 customers at A, B, C and D. On average, which is the lowest? Okay, so let's think of a box plot in general. This line here represents your lowest value. This represents your highest value. This is your lower quartile, which is 1/4 of the way through. This is the median. And this is the upper quartile. So if we're looking for the lowest queuing time, we're looking for the one that has the lowest median, which we can see is here, which is C, and our reason would be it's the lowest median. And when we talk about consistency, so now the next question is at which supermarket were the queuing times most consistent? So let's think about what we mean by consistency. Consistency talk in this case is the interquartile range, which is your difference between your upper quartile and your lower quartile. So the smaller the case, the more consistent it is. So it's clear to see here that B has the smallest box, so the smallest interquartile range. So that's supermarket B, and that's because it's the lowest interquartile range. Okay, so we're going to now circle the number closest to 29 cubed. Let's think, this is non-calculator, so we want to make it easy. So let's pick 30. 30 times 30 times 30. 3 times 3 times 3. It's going to give you the 27. You've got 1, 2, 3 zeros, so it must be 27,000. Work out the exact value for 3/4 to the minus 3. Well, as soon as you see this minus, you're going to flip it. So it's the same as 4 over 3 cubed. So think 4 cubed over 3 cubed. So 4 cubed is the same as 4 times 4 times 4 over 3 times 3 times 3. 4 times 4 is 16. Times 4 again is going to give you 64. And then 3 times 3 times 3 is going to give you 27. So you've got 64 over 27. Right. Question 18. Right. Beth and Mia translate documents from Spanish to English. A set of documents that would take Beth 8 days would take Mia 10 days. Beth starts to translate the documents. After 2 days, Beth and Mia both work on translating the documents. How many more days will it take to complete the work? Okay, so if Beth starts and Beth works for 2 days, so if it would normally take Beth 8 days, that means she's done 2 out of the 8 days, so 1/4 is completed to start with. So that means they've got 3/4 left to do in the remaining days. Okay, so if we think about it, every day Beth completes 1/8 and Mia completes 1/10. So if we add those up, let's use a butterfly, we've got 10 plus 8 over 80. So that gives us 18 over 80, which is the same as 9 over 40. So we've got 3/4 left, and we're dividing it by 9 over 40. Remember, kiss and flip. 40 over 9, that cancels, that becomes 10, that becomes 1, that becomes 3, and we're left with 10 over 3, which is the same as 3 1/3. Now, if your head doesn't sort of make sense to you, pick a number. And the number that I would pick would say, let's, for example, say we've got a set of documents and the number of pages or the number of documents is 80. So we're going to say Beth starts on these 80 documents. The reason I chose 80 is because it goes into 8 and 10. You'll get to exactly the same answer. So Beth starts, and normally it would take Beth 8 days to do all 80. So therefore, in 1 day, she's doing 10. So Beth starts in 2 days, she finishes 20. So now there's 60 left. Okay, so out of those 60, each day, well, we said there's 80 to start with. So 80 to start with, Beth every day can do 10. And Mia every day can do 8. So altogether, they each can do 18 if they work together. There's 60 left. So you're going to have 60 divided by 18. So 60 over 18. So we can cancel that down, divide both by 6 to give you 10 over 3, and we're in the same place. We've got 3 1/3 days. It doesn't matter which way you do things. If you can't see it in terms of fractions, just pick numbers. That tends to work in most questions. Right, let's have a look at question 19 now. In a chess club, there are X boys and Y girls. 5 more boys and 8 more girls join. So we're the X boys to start with, and we're going to add 5. And they're Y girls, and we're going to add 8. Okay. We're told there's half as many boys as girls. So that means there would be half as many boys as girls. So if we do 2 lots of the boys, it's going to equal the number of the girls. So if we open that up, we get 2x plus 10 equals y plus 8. We want to make y the subject, so I'm going to flip those round to make it easier. And we can minus 8 from both sides, and we get the answer. It's 2. And then part B says, if instead 10 more boys, so we've got x plus 10, and 1 more girl, y plus 1 join, they'll be the same number. Okay, so it'll equal the same thing. So now we're going to work out, so we've got a simultaneous equation, but it's easier. Why don't we just make it y equals again? So y plus 1 equals x plus 10, minus 1, minus 1. So y equals x plus 9. Okay, so what we're going to do is we're going to now substitute in, so we can eliminate the y's, or we can just take them away. It doesn't really matter how you do it. So if we say that's 1 and that's 2, we do 1 take away 2, y take away y is going to give you 0. 2x take away x is going to give you x. 2 minus 9 is going to give you minus 7. So x equals 7. Now if we sub that back in to any equation, let's sub it into the top one, we get y equals 2 times 7, which is 14, plus 2, which is going to give us 16. So you could have solved those simultaneous equations in a few different ways. That's just one of the ways. Okay, question 20. We want to prove that QS is not a diameter. Okay, so when you get something like this and you don't really know what you're doing, or you're not sure, just look at the diagram and start to label things. So if we have a look here, we can see that QPR must be 27. Because these two angles are in what we call the same segment. Can you see? You kind of get a bow shape, which is also typical of that. Let's see if I can show you that clearly. So you can see you've got a bow shape. So whenever you get that sort of shape, these two angles are the same. Okay. So we know that's 27. So we would write QPR equals 27 degrees, and its angles in the same segment. Right, so we've got those two angles to start with. Then if we have a look, we could work out XPS. So we could work out this angle here, or even this angle here, because it's an isosceles triangle. So we'd say XPS equals 180 minus 50 divided by 2. And the reason for that is angles in an isosceles triangle. So the base angles in an isosceles triangle are the same, are equal. Okay, so can we find any other angles that we don't know? So hopefully we've got QPS, we can now see. So if we have a look, we don't need any more angles because we're trying to see whether this is a diameter. If this is a diameter, this triangle here would be right angled. So we're saying, is this a right angle? So we'd say 27 plus 65, what does that equal? It equals 92, which is not a right angle. So it's not 90 degrees, therefore not a diameter. Those 3 dots mean therefore. Because when you've got a diameter, the angle that it goes through in a circle is always a right angle. Okay, we've got the first 4 terms are for quadratic sequence. So these are quite fun. These are quite easy. So you find the first difference. So 26 minus 11, 45 minus 26, and 68 minus 45. And then you find the second difference. You're not expecting the first difference to be the same, but you are expecting the second difference to be the same. If your second difference is not the same, you've done something wrong. If it said it's quadratic, go back and double check. So you take the second difference and you divide it by 2. And that becomes your n squared. So now we know for definite, so if I'm going to rewrite this equation, we've got n is 1, 2, 3, 4. We've got 11, 26, 45, 68. And we now know we've got 2n squared. So we fill in our 2n squared. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 6. So sorry, times 2 is 8. Don't know what I'm doing there. 3 squared is 9 times 2 is 18. Let's just rub that out and make that clear. Right, 4 squared is 16 times 2 is 32. And then we're going to say to ourselves, we're going to do a takeaway sum. We're going to do 11 take away 2. So 11 take away 2 gives us 9. So we're going to do this take away this, this take away this, this take away this, this take away this. So 26 take away 8 gives you 18. 45 take away 18 gives you 27. 68 take away 32 gives you 36. So this is your new sequence without the 2n squared. And you find the difference again. And this time the difference is 9. So straight away you can write 9n. So 9n in this case would be 9, 18, 27, 36. And if you notice, this plus this gives you that. So you've got 2n squared plus 9n. So you find the first sequence and you follow it with the second sequence. Right, question 22. So this is an algebraic fraction. If you haven't already looked at the algebraic fraction questions, I think it's either this question or one very similar to it, which we work through. So remember, with algebraic fractions, you're going to treat them exactly like you treat any fraction. So you take your diagonal and you take your 2 diagonals and you multiply them exactly as you would if it was numbers. And then you multiply the 2 bits on the bottom and that's your denominator. So you've put your fraction together and it equals 1. Now, we can multiply this up to here. So we get x minus 2 plus 7, x plus 4 equals x plus 4, x minus 2. So now let's open out all the brackets. When we open out the brackets, we get x squared minus 2x plus 7x plus 28 equals x squared 4x minus 2x, so plus 2x minus 8. And what we're going to do is we're going to put everything onto one side. Doesn't matter which side you put it on. So let's put it all onto the left-hand side. X squared minus x squared. These are going to cancel. 7x minus 2x is 5x. Minus 2 more x is going to give us, so we've got 7 minus 2, which is 5x, minus 2x, which is going to give us 3x, plus 28 equals minus 8. So 3x equals minus 8 minus 28. which gives you minus 36. 3 times something gives you minus 36. That something is minus 12. So x must be minus 12, and we can always check it by putting it back in. Right. Question 23. Prisms A and B are similar. The cross sections are shaded. Okay, work out the area of the cross section of B. They're in the ratio 4:9. We have the volume and we have the length. So let's think about this. Whenever we're going to have lengths. So say we have our lengths A and B. If we've got a ratio of the lengths and we want to go to the area, we've got to square those ratios. And if we want to go, so we're squaring, we want to go back to the length, we take the square root. We can't, if we want to go to the volume, we've got to cube it. And if we've got to go back from the volume, we're going to take the cube root. Okay, so where are we now? We're given the cross-sectional area of, we're given the area, we're told that's 4:9. So to go to the length, so this is the volume, and this is the area. So if we wanted to figure out what the length is, we would have to take the cube root of both of them. Cube root of 4 is 2, and the cube root of 9 is 3. If we wanted to know the volume ratio, we'd have to cube it. So 2 cubed gives you 8, and 3 cubed gives you 27. So now, if we know the volume of prism A is 480, so we know that for the volume there. We know the length of B is 30, and we want to work out the area of B. Okay, so all we're going to have to do is we're going to say, let's first work out the volume of B, and then we can divide it by the length and hopefully get the area. So if we go 8 to 480, how do we do that? So we say 48 divided by 8 is 6. So we've multiplied this by 60. So we need to do the same on this side. So we're going to do 27 times 6, which is 162, and add a 0. So now we know the volume of prism B is 1620. We can divide it by the length that we're given, and we should be able to find out the area. So then we're now left with 162 divided by 3. 16 divided by 3 is going to give us 15, remainder 1, and 54. So our answer is 54. I hope that makes sense. So you're remembering that the volume of anything is your cross-sectional area times your length. Okay, we're in the final bit of this paper. That's why they've started to get a little bit trickier. So I think there's usually 26 or 27 questions. So we're almost there. All right, let's have a look at question 24. Okay, so we've got, again, fractions, but this time they're written as surds. But again, you treat it exactly the same way. You could simplify it to start with. I think you could make them both over root 10, which might be easier because then you're just taking it away. So if we have a look at that and say, well, we can make that root 10 because we know root 5 times root 2 will be root 10. So we can times top and bottom by root 2. So we'll get 2 root 6 root 2 over root 10 minus root 3 over root 10. Okay. So let's see, that's the same as 6 times 2, which is 12, minus root 3 all over root 10. Okay, root 12, that's a little sidebar. Root 12 is the same as root 3 times root 4. Root 4 is 2, so we get 2 root 3. So we've got 2 lots of 2 root 3. So 4 root 3 minus root 3 over root 10 which gives us 3 root 3 over root 10. We hate surds on the bottom, so we're going to get rid of that root 10 by timesing top and bottom by root 10. So we end up with 3 root 30 over root 10 times root 10, which is 10. And there's your answer. C is 3 and D is 30. Right. Question 25. So we've got a negative quadratic, which means we know that this is of the form minus ax squared plus bx plus c. So what we know for definite is we've got our plus c is 18, and we don't know what our a or b is. However, we can see that if we were to write it so that in completed the square form, what would we get? So when we have a negative, so we've got two ways. If we have a positive one, we get x plus b squared plus c. If it's a negative completing the square, it looks like that because there's a minus in front. So because we've got a negative one, we can think of it as c minus a x plus b squared. Right, now in this case we can see the b is 0 because that's our minimum point, and we can see that the c is 18. So we get y equals 18 minus ax squared. And now all we have to do is sub in a point. So let's take the 3. We can see when x equals 3, y equals 0. So we can say 0 equals 18 minus 9a. 9a equals 18, so a equals 2. So my final answer would be y equals 18 minus 2x squared. Another way to have done this is to recognise that it's, number one, a negative quadratic, but it would have come from something multiplied by 3 plus x, 3 minus x, because that's where your roots are. And then you would get y equals a, 9 minus x squared, and then you could sub in this point here to give you your a equals 2. Doesn't matter which way you do it, you'll get the same answer. This is a little bit tricky, and this is now like right at the end of the paper. This is definitely a level 9 question. Okay, question 26. Right, we've got the area of a triangle. It's not a right angle, can't use half base times height. So your brain should straight away go half AB rather, sine C. Okay, so the angle we know is this, so this must be our C. So this is small c, and this is A, and this is B, for example. It doesn't matter which one's which. So our area, we're told, is 25 root 3, and that's the same as a half times 20 times x times sine 60. Okay. Right, so we're going to be able to find the x, which means hopefully then we can use a different rule to find the w. Times the 2 up there, we could cancel that to become 10. Sine 60, so if you remember our triangle from the previous question, we had split this one, so that was 30, that was 60, that's 1, that's 2, that's root 3. So sine 60 is so opposite over hypotenuse. So you'll get root 3 over 2. So we've got 25 root 3 equals 10 times x times root 3 over 2. And if we notice there's a root 3 on both sides, get rid of those. Cancel the 2 with the 10 and make that 5. And that makes it really easy. Divide both sides by 5. And we get x equals 25 divided by 5, so it's 5. So we've got x is 5. So we now know this bit here. It still doesn't help, it still hasn't told us w. To get w, we've got to use the cosine rule. This is why it's 5 marks. So we've got the cosine rule, if you remember, is a squared equals b squared. So this time, this C for this equation is actually my A. So this becomes my big A, so therefore this is small a, and this can be B and C, and it doesn't matter which order. So we've got W squared equals 20 squared plus 5 squared minus 2 times 5 times 20 times cos 60. So W squared equals 20 squared, which is 400, plus 25 minus 2 times 5 is 10, times 20 is 200. Cos 60, if we have a look at here, we've got our adjacent over hypotenuse, which is a half, and that's all together. So we get 425 minus, that's 100. So W squared equals 325. Now if you look at the question, it wants it as A root B. Now those are quite horrible. So we get W equals the square root of 325. Now we kind of look at that and go, I'm not sure what it divides by, but there's a 25 in it. And we know 25 is an exact square, so hopefully it divides by 25, which it should do, because we know 100 goes into 25 4 times. So 300 must go in 12 times, plus the extra 25 tells us it's 13 times. So we've got 13 times 25, which is root 13 root 25, which is root 13 times by 5, which we can write as 5 root 13. Okay, final question. Right, so we've got, all right, question 27. We've got alpha is an acute angle. Cos alpha equals k. So what we have to realise about cos is to get the next one, we do 360 minus. So if you have a look, if I was to draw this graph, and if I wanted to get the next one along, this space here is the same as this space here. So your rule for cos is 360 minus alpha will be the same as cos alpha. Now also, cos repeats every 360. So every 360 the graph repeats. What we notice here is if this is alpha and we're minusing this space, we're going to be left with, so if we minus this alpha from 180, we're going to get minus k. So we're left with, because it's symmetrical, 180 minus alpha is going to be that. Now we already said that the cos repeats every 360. So 360 plus alpha will just get you back to your original of k. I hope that makes sense. Okay, so that's the non-calculator paper. We'll be going through this entire set and probably getting through that this week.